Rate limiting is a key security and performance optimization technique for web applications. In Express.js, rate limiting is crucial for controlling the number of requests a client can make within a specific period. This is particularly important for public APIs, where clients might abuse the system with an excessive number of requests, leading to server overloads or denial of service, DDoS attacks. Rate limiting can help mitigate these risks by enforcing strict limits on the frequency of requests. In this guide, we'll explore how to implement rate limiting in Express.js, covering the core concepts, the benefits it offers, and how to integrate it into your application effectively. We will also delve into middleware like Express Rate Limit, explore different rate limiting strategies, and discuss advanced solutions like Redis integration for distributed systems. Rate limiting refers to the practice of controlling the number of requests a user or client can make to an API in a given time period. By limiting requests, you protect your server and resources from overuse, ensuring a stable environment for legitimate users while preventing abuse. Rate limiting is essential for preventing server overload, mitigating DDoS/DDoS attacks, ensuring fair resource usage, and improving user experience. Express.js is one of the most popular frameworks for building APIs in Node.js. By incorporating rate limiting, Express apps benefit in several ways: enhanced security, better API performance, cost efficiency, and improved fairness. To implement rate limiting in Express.js, you can use middleware, which acts as an intermediary between the client and the server. A popular choice for implementing rate limiting is the Express Rate Limit middleware, which makes configuring rate limits simple and effective. Start by installing the Express Rate Limit package from npm. Next, set up the middleware in your Express application. You can configure the rate limiter to limit the number of requests per client, usually based on IP address, within a specific time window. Here's an example of setting up the basic rate limiting middleware in your Express.js app. This example sets a limit of 100 requests per IP address every 15 minutes. If a client exceeds this limit, they will receive a message notifying them of the rate limit. Sometimes you might want to apply different rate limits for different routes. For example, you may want to allow a higher rate of requests for publicly available information, but restrict heavy API endpoints like user authentication. Here's how to set custom rate limits for specific routes. While the basic rate limiting is effective, you may need more advanced configurations depending on your application's needs. In many cases, rate limiting by IP address is the most common approach. However, IP-based rate limiting may fail to prevent abuse from users behind proxies or NAT. A more sophisticated strategy would involve combining IP-based limiting with a CAPTCHA or other verification system. You can customize rate limits based on user roles. For instance, authenticated users or premium users could have a higher request limit compared to unauthenticated or free-tier users. For applications that are deployed across multiple servers or instances, using a shared rate limit store like Redis can help synchronize rate limits. Redis stores the request counts and allows you to implement distributed rate limiting. First, install the Redis and Rate Limit Redis packages. Then, configure Redis-based rate limiting. Rate limiting is a vital component for ensuring the security, performance, and stability of your Express.js applications. By limiting the number of requests that a client can make in a given time period, you protect your server from abuse, mitigate the risks of DDoS/DDoS attacks, and ensure fair access to resources. Implementing rate limiting in Express.js is simple with tools like Express Rate Limit, and with advanced configurations such as Redis for distributed systems, you can scale your applications efficiently while maintaining optimal performance. By following this guide, developers will be equipped to build secure, high-performing APIs that can handle heavy traffic while ensuring a positive user experience.